Hey, welcome back to Well, That's Interesting. I don't really see this as a bonus, but thanks anyway, edition. Today is bonus. Repressed genes can come back to life after you die. My friends, my overworked and underpaid friends, it's that special time of year when you can go on ahead and tell your boss to suck it, and I take the week off. That's right, it's Labor Day. It is upon us, and I thought, what better way to celebrate but to let you know that after you die, some of your cells continue to chug along and work. And I'm not even talking about a few hours after you pass, I'm talking days. There are even dormant genes that spring to life. No pun intended. It is my honor to share with you a video from Science magazine called Undead Genes. Why do some genes turn on after death? And if you like, you can watch along and admire all the cute animations on the tube of you. I'll also have screenshots over at our social media stuffs too, so there was no way I was going to leave you empty-handed, my friends. Please enjoy this brief 4-minute video that will leave you a little uncomfortable and pondering your existence. Oh, and hi. I'm Jill Chacha, by the way, and if this is your first time listening, welcome to the flock, my vigorous business goose. A full episode, also full of something weird and wonderful, will drop next week. But in the meantime, here we go. Undead genes. Why do some genes turn on after death?
Imagine you're dead. No heartbeat, no brain activity, no breath. That seems pretty final. But at the cellular level, only part of you is dead. Some of your cells are still fighting the good fight. Scientists want to know what's going on inside those lingering cells. So researchers looked at the activity of more than 1,000 genes in both zebrafish and mice for up to 4 days after they died. Groups of genes related to immune response, inflammation, stress response, and cancer were all more active. Even more surprising, genes normally only seen during development were also suddenly active. These genes are tightly locked down by cells after the embryo develops and never expressed again, until perhaps the organism dies. So why do they revive? It might be that some conditions inside the cell after death resemble those before birth, but they don't know for sure. An alternative reason developmental genes turn on might lie with changes in epigenetic regulatory genes, which control gene activity by restricting access to the DNA. The activity of some of those regulators was actually shown to increase after death. Developmental genes are physically tucked away in the genome, but if the regulators spin out of control, those genes could suddenly become accessible and start expressing. There isn't really a why question here. It doesn't seem likely that there's a purpose to these genes turning on. That's because genes in a dead organism can't be acted on by natural selection. There's no evolutionary advantage to turning them on after death. Probably. If an organism isn't quite dead, there could be some advantage to ramping up some genes, like those related to stress responses and recovery from injury. But there's not enough data to know for sure, and few other studies have tackled this question. One that did looked at human tissue, over 9,000 samples from 36 different types. After death, gene expression in brain and spleen tissue was relatively stable, but genes in muscle tissue went crazy. More than 600 either increased or decreased their activity. And those increases in gene expression waxed and waned in a way that suggested biochemical machinery was still working. What can we learn from this? Patterns of gene expression could be used to estimate time of death, something that current forensic techniques don't always get right. And the experiment that looked at human samples identified the types of tissues that might be most helpful to forensics: skin and the layer of fat directly beneath. And that's not all. Patients that get organ transplants from dead donors could start receiving better care, the more we learn about gene expression after death. These changes in gene activity could even help explain why some transplant recipients are at an increased risk of cancer. It's also important for researchers to understand gene activity in tissues that can only be obtained after death. If death alters our genes, scientists need to know how that affects the tissues they study. And we can't rule out simple curiosity as a driving force for this research. What our genes get up to after death is a beguiling mystery, and one we've only begun to consider.
So thank you for listening, rating, subscribing, telling your friends about their dead body. Tell them this weekend over the barbecue. Just bring it up when there's like a silence. Just bring it up. And I'll see you next week for an episode that may or may not be related to this very topic. Oh my. I cannot wait. I'm not going to give it away. But until then, stay interesting.